In this video, we will look into the arithmetic and geometric progression questions from the 2023 question paper. This question is from the paper 12 FM 23. The circumference around the trunk of a large tree is measured and found to be 5 meter. After 1 year, the circumference is measured again and found to be 5.02 meter. Given that the circumferences at early intervals form an arithmetic progression, find the circumference 20 years after the first measurement. So the first value is given as 5 and second value is 5.02. Okay, and it is an arithmetic progression. So we have to find the value of d. D is the difference between the any two consecutive terms in the arithmetic progression. So here it is 5.02 minus 5, which is equal to 0.02. Okay, and let us take the value a as 5. Find the circumference 20 years after the first measurement. 20 years after the first measurement means you have to take the n value as 21. After 20 years, it is 21st year. We are measuring again. So n is 21. So the nth term formula is, let us substitute the value of a and n in the nth term formula of the arithmetic progression, which is a plus n minus 1, which is 20, multiplied by d. D is 0.02, which is equal to 5.40. 5.40 is the answer. The next part of the question is given and state that the circumferences at early intervals form a geometric progression. Find the circumference 20 years after the first measurement. Here also it's given 20 years after the first measurement, that is 21st year we are measuring again. You have to take n value as 21. And the first term is a is 5 and the second term is 5.02. In our geometric progression, the r value can be calculated for any two consecutive terms. The second term divided by the first term. This is equal to 1.004. And a is 5. The nth term formula is a, which is 5, multiplied by r power n minus 1. Here it is 20, which is equal to 5.42. I am writing in 3SF. This question is from the paper 11 MJ 23. The first three terms of an arithmetic progression are p square over 6, 2p minus 6 and p. Given that the common difference of the progression is not 0, find the value of p. So common difference of the progression is not 0. That is, D is not 0. So the first term is p square divided by 6. Second is 2p minus 6. And the third is p. So let's find out the value of D. D is the difference between any two consecutive terms. So p minus 2p minus 6 equal to minus p plus 6. So this is the D value, and A value is p square over 6. So p square over 6 is our A value. This is A plus D, and this is A plus 2D. So A plus 2D is P. Okay. And we know the A value is P square divided by 6 plus 2 times the difference is minus P plus 6 equal to P. P square divided by 6 minus 2P plus 12 minus P equal to 0, or this can be written as P square minus 2P and minus P is minus 3P. We will take 6 as common denominator. So we'll get 18P plus 72 equal to 0. Let us factorize P square minus 18P plus 72 equal to 0. We will get P minus 6 multiplied by P minus 12 equal to 0. So P is equal to 6 or P is equal to 12. When you substitute the value of P as 6 in finding D, we will get D value as 0. But it's given D is not equal to 0. So P cannot be 6 since D is not equal to 0. Okay. So we will take P value as 12 only. Using this value, find the sum to infinity of a geometric progression with first two terms p square over 6 and 2p minus 6. So we need to find the sum to infinity, and p square over 6 is the first term, which is nothing but 12 square divided by 6 and 2 multiplied by 12 minus 6, that is 24 and 18. So these two are the first two terms of the geometric progression series. So A is equal to 24 and the value R is the ratio of the number 18 and 24. That is the second term divided by the first term. So this is equal to 3 over 4. And sum to infinity Formula is A, that is 24, divided by 1 minus R. R is 3 over 4. On simplifying this, we get the value as 96. The next question is from the paper 12 MJ 23. The second term of a geometric progression is 16 and the sum to infinity is 100. Find the two possible values of the first term. The second term of a geometric progression is AR. AR is 16 and sum to infinity, that is A divided by 1 minus R, is 100. From this, we will take the value of A as 16 divided by R. Let us substitute that here. 16 divided by R divided by 1 minus R equal to 100. Or this can be written as 16 equal to 100 R multiplied by 1 minus R. 16 equal to 100 R minus 100 R square. So 100 R square minus 100 R plus 16 equal to 0. Now let us factorize this one. We get the R value R equal to 100 plus or minus square root of 100 square minus 4 multiplied by 100 multiplied by 16 divided by 2 multiplied by 100. On simplification of this, we get the R value as 4 over 5 and 1 over 5. So we need to find the first two possible values of the first term. So we need to find the value of A. We know AR equal to 16. So A equal to 16 divided by R, which is 16 divided by 4 over 5. So which is equal to 20. Another value of A is 16 divided by 1 over 5, which is equal to 80. So the two possible values of A are 20 and 80. These are the two possible values of A. The next part of the question is, show that the nth term of one of the two possible geometric progression is equal to 4 power n minus 2 multiplied by the nth term of the other geometric progression. So for two values of A, for the two possible values of A, we will get two nth term. So we need to equate both. So the nth term, when A is equal to 20 and R is equal to 4 over 5, the nth term is equal to I'll write this as geometric progression 1. Nth term of geometric progression 1 is a multiplied by r power n minus 1. So a is 20 multiplied by r is 4 over 5, the whole power n minus 1. For the next possible value of a, which is 80, r is 1 over 5. Geometric progression of this sequence is 80 multiplied by 1 over 5, the whole power n minus 1. So it's given one geometric progression is equal to 4 power n minus 2 multiplied by the nth term of the another geometric progression. So to prove that, let's write this as 20 multiplied by 4 power n minus 1 multiplied by 1 divided by 5, the whole power n minus 1. And let us write this geometric progression 2 also as 20 multiplied by 4 or 4 multiplied by 20 multiplied by 1 over 5, the whole power n minus 1. Geometric progression 1 is equal to 20. I will just rearrange this so that it's easy to substitute. 4 power n minus 1 multiplied by 20 multiplied by 1 over 5, the whole power n minus 1. Now for this term, let us substitute the value in terms of geometric progression 2. Gp2 divided by 4 will be equal to this value. So 4 power n minus 1 multiplied by Gp2 divided by 4. When the 4 comes to the numerator, it will be 4 power n minus 2 Gp2. So Gp1, the first progression, is equal to 4 power n minus 2 multiplied by the another progression Gp2. So hence we proved it. This question is from the paper 13MJ23. A progression has first term a and second term a squared divided by a plus 2, where a is a positive constant. For the case where the progression is geometric and the sum to infinity is 264, find the value of a. So the first term is a and the second term is a squared divided by a plus 2. So it is a geometric progression. Sum to infinity is a divided by 1 minus r equal to 264. Find the value of a. So for that, first let's find out the value of r. R is the second term divided by the first term. So a square divided by a plus 2 divided by a, which is equal to a divided by a plus 2. Let us substitute the value of r in the sum to infinity. So a divided by 1 minus a divided by a plus 2 equal to 264. This can be written as a divided by a plus 2 minus a divided by a plus 2 equal to 264. So this can be written as a multiplied by a plus 2 divided by 2 equal to 264. So a square plus 2a equal to 528. Or this can be written as a square plus 2a minus 528 equal to 0. Let us find the value of a by using quadratic formula. Minus 2 plus or minus 2 square, that is 4, minus 4 multiplied by 1 multiplied by negative 528 divided by 2. So we get the value of a as 22 and minus 24. So it's given a is a positive constant, so the value of a is 22 only. The next part of the question is, for the case where the progression is arithmetic and a is equal to 6, determine the least value of n required for the sum of the first n terms to be less than negative 480. So it's a arithmetic progression and a is given as 6. So we need to find the value of d. For that, first let us write the progression terms. A is 6, and what's the next term, which is a square divided by a plus 2. So 6 square divided by 6 plus 2, that is 36 divided by 8, or this can be written as 9 over 2. So since it's an arithmetic progression, we need to find the value of d. D is the difference between any two consecutive terms. So d is equal to 9 over 2 minus 6, which is equal to minus 3 over 2. So it's given, determine the least value of n required for the sum of the first n term to be less than negative 480. So the sum of n term formula is n divided by 2, 2a. So a value is 6, so 12 plus n minus 1 multiplied by d, which is negative 3 over 2. And it's given this is less than negative 480. So 6n plus minus n into n multiplied by negative 3 over 2 is 3n square divided by 4 plus 3n divided by 4 is less than negative 480. So negative 3 over 4n square and add the n terms 6n and 3n over 6, we will get 27n divided by 4, which is less than negative 480, or we can write 480 as less than 0. So this can be written as minus 3n square plus 27n plus so 1920 as less than 0. Now divide the whole term by negative 3. So we will get n square minus 9n minus 640 is greater than 0. Now let's find the value of n by using the quadratic formula. 9 plus or minus square root of 9 square minus 4 multiplied by 1 multiplied by negative 640 divided by 2. We get the n value as 30.19. So another value we are getting as a negative value. N is the number of terms in a sequence, so n cannot be negative. So we will take n value as 30.19, that is the positive value. Since we get a 30.19, that means 30 will not be enough, so we need 31 terms. So n is equal to 31, which is the least value of n.